Imagine holding the universe in your hand. Not the literal universe, of course, but something equally astonishing, the intricate world inside your smartphone camera. We use it every day, often without a second thought. But behind that tiny lens lies a feat of engineering that pushes the boundaries of physics and material science. Join us as we journey into the microscopic realm, revealing the unseen forces that make every photo possible. Let's start with the heart of your camera, the image sensor. Most smartphones use CMOS sensors. These sensors are covered in millions of microscopic, light-sensitive pixels. Each pixel acts like a tiny bucket, collecting photons, particles of light. The more photons that hit a pixel, the stronger the electrical signal it generates. This signal is then converted into a digital value, representing the brightness of that point in the image. But the physics gets even stranger. The photoelectric effect, a phenomenon explained by Einstein, is at play. Photons strike the silicon atoms in the sensor, releasing electrons. These electrons are then collected and measured. It's a quantum dance happening millions of times per second, all within a space smaller than a grain of sand. Now, consider the lens. It's not just a piece of glass. It's a complex system of precisely shaped lenses, often made from multiple types of glass and plastic. Each element is carefully designed to bend light in a specific way, correcting distortions and focusing the image onto the sensor. The materials science involved is incredible. Manufacturers use exotic glasses with precisely controlled refractive indices. These materials are often doped with rare earth elements to achieve the desired optical properties. Some lenses even incorporate aspherical elements, which have a non-spherical shape, allowing for sharper images and wider apertures. The precision required is astounding. Tolerances are often measured in nanometers. The manufacturing process is a marvel of miniaturization. Image sensors are fabricated in clean rooms, environments cleaner than operating rooms. Dust particles can ruin the delicate circuits. Lithography, a process similar to printing, is used to etch the intricate patterns onto the silicon wafers. Layers of materials are deposited and etched, creating the transistors and other components that make up the sensor. The lenses are also manufactured with extreme precision. They are ground and polished using computer-controlled machines. Interferometry, a technique that uses light waves to measure distances, is used to ensure the lenses meet the required specifications. The final assembly is often done by robots, ensuring consistent quality. Beyond the sensor and lens, there's a sophisticated image processing pipeline. Raw data from the sensor is processed by complex algorithms. These algorithms correct for imperfections in the lens and sensor. They also perform noise reduction, color correction, and sharpening. Many smartphones now use AI to enhance images, identifying objects and scenes and optimizing the settings accordingly. This image processing happens in real time, allowing you to see the final image on your screen almost instantly. It's a testament to the power of modern computing. The miniaturization of camera technology is driven by Moore's law, the observation that the number of transistors on a microchip doubles approximately every 2 years. This has allowed manufacturers to pack more and more functionality into smaller and smaller spaces. But there are limits. As transistors get smaller, quantum effects become more pronounced, making it harder to control their behavior. Researchers are exploring new materials and architectures to overcome these limitations. One promising area is the development of metamaterials, artificial materials with properties not found in nature. These materials could be used to create even smaller and more powerful lenses. So the next time you snap a photo with your smartphone, remember the incredible science and engineering that went into creating that tiny camera. It's a window into a microscopic universe, a testament to human ingenuity. And it's a reminder that even the most everyday objects can hold extraordinary secrets. The unseen world is waiting to be discovered. Keep exploring.